Next thing we're going to be learning about in class is from chapter 9 in your book, and it's the idea of correlation. Now, this week we're just going to get a quick introduction to what correlation is and how it works. There's no assignment this week, but we want you to have a little bit of background so that things go quicker and easier when we get into the details next week after you're done with your test. Tells you here that a correlation is just a relationship between two variables. Everything we've done in statistics so far, we've just looked at one variable, but suddenly we're moving on and we're looking at two things at the same time. The question you're answering with correlations is, as one thing goes up, can you tell whether the other one is going up or going down on the whole? There are a couple of you that I suggested for your project would want to look at correlations. For instance, there's one person that is trying to figure out whether sports teams that spend more money have better performance overall. And you could figure the idea there that as the spending goes up, does the performance go up? That's going to be a correlation. And we're going to look at a bunch of other correlations today just to give you examples of how things work. Most often when we show correlations, we use what's called a scatter plot. And you're going to see a bunch of pictures of scatter plots today. What a scatter plot does is it just shows a bunch of points, a bunch of dots, that are showing you the two variables that are going on. The graph I'm showing you here I found a few years ago where it's talking about the relationship between freedom in a country and happiness. And on the x-axis, they're looking at what percent of people in a country would describe themselves as happy or satisfied with life. And the y-axis is showing you how free those countries are. And you can see the general trend is as one thing goes up, the other one goes up too. This is sort of interesting to look at where some of the countries are. You can see that actually the country of the world that is actually the happiest is Iceland. And it's interesting to do that. I've been to Iceland, and it is a country where everybody basically is very happy. It's also a country that's one of the freest countries on earth. And the place I got this from, the headline said, "The key to happiness is freedom, not money." When I visited Iceland, it was actually right after they had had a severe crisis in their economy, and almost nobody had much of any money at all. And yet it was one of the happiest places I visited. On the other hand, you can see that the least happy places in the world are in Eastern Europe. You have places like Ukraine and Moldova and Belarus. And those are also some of the places that are the least free overall, and that's the relationship they're trying to show you. Something you'll notice on scatter plots in general is they're not perfect. There are places that are fairly happy but not overly free. On this one, you'll see some African countries like Nigeria and Ghana that are in that list, or China, which is one of the least free places in the world, but overall fairly happy. Those are exceptions, though. The general trend is upward, that as people are more happy, they're also freer, or vice versa. So again, we're going to look at a whole bunch of different scatter plots. This one is showing you the relationship between how much fat is in your diet and cancer. And you can see that we do have places that have very fatty diets, like the United States, that also tend to have high cancer rates. Now, we, I guess, could be fortunate that we're not in the Netherlands or New Zealand that are higher than us. If you want to have a low-fat diet, think about Thai food. And that, of course, is almost a vegan diet in many cases. And it also has one of the lowest rates of cancer that you have in the world in Thailand. So again, not a perfect correlation, but the general trend is more fat does tend to lead to more cancer. Here's a graph that is a little bit more tightly packed, and it's showing you the relationship between experience and income. The idea is that typically the more experience people have in a job, the more money they make. Here we're looking at how long you delay getting service on a vehicle and what the cost of that service is likely to be. And the point of it is, if you postpone getting that service, it's going to end up costing you more money. And that's the whole idea, that when one thing goes up, the other one's going to go up as well. The scatter plot actually has a whole bunch of different things shown on the same graph, but the main thing they're showing is the relationship between income and religious attendance in different states. So on the x-axis, they're showing you the average income in different states in the United States, and then we have what percentage of the people in those states end up going to church every Sunday. And there's some interesting relationships. One state I'm fairly familiar with is the state of Mississippi, where I went to grad school, which is the poorest state in the country. It also has the highest rate of church attendance of any of the states in the country. On the other hand, if you go toward the other end of the graph, you'll see that some of the wealthiest states, which mostly are in the Northeast, have some of the lowest rates of church attendance overall. Now, they've also coded this with like red states and blue states, which is an interesting thing to show with it as well. But the key idea is typically the wealthier states have lower church attendance than the poorer states. Another scatter plot here that's looking at grip strength and arm strength. And the basic idea is the stronger you are on one of those measures, the stronger you're likely to be on the other measure. Again, it's not a perfect correlation. It's kind of all over the place, but the general trend is upward. A very common correlation is between height and weight. Typically, taller people weigh more than shorter people, and that's exactly what this graph is showing. Now, the reason that you see dots all over the place is that there are, in fact, short, fat people and tall, skinny people, but in general, the taller you are, the more you're likely to weigh. This graph is looking at the relationship between car weight and gas mileage. And the whole idea on this is if you have a heavier car, it's likely to get poorer gas mileage. I can definitely relate to that. The last car I had was actually a Chevy Metro, one of the smallest cars that was ever made. The great thing about that car is it got awesome gas mileage. It would do 40 miles to the gallon regularly on the different mileage, so it cost practically nothing to drive. I traded that for what's still a small car, but it ends up being a much heavier car. It's a Mitsubishi Eclipse. And that car, because it's heavier, it gets a lot poorer gas mileage overall. Something we don't often think about in the Midwest is the idea of elevation and temperature. But if you were to go hiking out in the mountains, that's something that ends up being very important. The higher up you are, the colder it is. And you do need to be aware that if you are at an elevation, the temperature is going to be lower. This scatter plot is showing the relationship between systolic and diastolic blood pressure. Those are just the two numbers you see when you record your blood pressure. Systolic's the top number and diastolic's the bottom. They always tell you that the classic blood pressure is 120/80. But what they're showing you here is when one of those numbers goes up, the second one is also typically going to go up. Here's a graph that's looking at what we would call a negative correlation. They're showing you the relationship between temperature and coffee sales. And basically it's saying that when it gets warmer, you're going to sell less coffee than when it's cold out. I purposely included this scatter plot because it actually shows what's true with an awful lot of correlations. Here they're looking at the relationship between scores on language and math tests for elementary students. And if you look at this graph, it looks like there's dots literally all over the place, and that is true. Now, you will notice they're packed a little bit closer together toward the center than they are toward the top left and the bottom right. This would be what we call a very slight positive correlation, which means that some kids who do better in language also do better in math, but really there's not much of a relationship between success in the two fields. This is a graph that I could have used as an example of a bad graph earlier in the year, because you'll notice they cut off the bottom, it doesn't start at 0. However, what they're showing you on it is a relationship between sleep and test scores, and they're basically saying that the more you sleep, the better you're likely to do on tests. The headline for this graph did it say, do pro basketball teams run up the score against bad opponents? And the answer is yeah, sometimes. They are showing you a scatter plot here, which is looking at the winning percentage of the opposing team and what the scoring margin was when the New York Knicks played them. And the idea was that typically the better the team you're playing was, the lower that scoring margin is likely to be. Now, you notice this is a pretty wide variation. It's not packed real close together. So that's why I said, yeah, sometimes. Here's a scatter plot that's showing you the ages of married couples, and the point they're making is typically the older the husband is, the older the wife's likely to be. This is a graph where the x-axis is showing the LSAT score, the law school admission test score, and the y-axis is showing you the salary for lawyers. The point they're making is typically people that did better on the law school test end up making more money when they're lawyers. Now, I'm not at all a physicist, so I can't really tell you the science behind this graph, but we're looking at the relationship between temperature and electrical resistance, and typically low resistances happen at high temperatures, high resistances happen at low temperatures. This is a very strong negative correlation. An actual study that was done at the University of Wisconsin looked at the relationship between beer that students drank and the grades they got on a test. And you can see your common sense probably would tell you that the more you drank before taking a test, the worse you were likely to do on the test. Now, sometimes I've had people that notice that we've got people that drank a whole 12 pack and still passed, but you do notice that the more you drank, the lower those scores were. I just showed you a whole bunch of examples of scatter plots, and it does turn out there is a lot of information that you can tell when you look at a scatter plot. You can tell whether we have a strong or a weak correlation. Basically, what I do by that is I look to see, are those dots packed really close together? That would be a strong correlation. Or are they spread all over the place, which would be a weak correlation? In the scatter plots we were looking at, the one about electrical resistance was by far the strongest because those were almost in a straight line. And the weakest one would have been the relationship between language and math tests where the dots were all over the place. You can also tell whether you have a positive or a negative correlation. All you're looking at there is the general trend of the dots upwards or downwards. The one about beer and what grade you got was a negative correlation because those dots went down. The more beer you drank, the less your score on the test was. On the other hand, we saw a graph that had a positive correlation in the one about the lawyers' test scores and their salaries. The lawyers that got better test scores tended to make more money. Here are some scatter plots that are just showing you all the different things that can possibly happen. At the top, you see a strong positive and a strong negative correlation. Typically, the stronger it is, the closer things are to being in a perfect straight line. And you can see those are packed pretty close together. When you have a weak positive or a weak negative correlation, you're going to see dots that are spread further apart. You can still tell what the general trend is, but it's not packed nearly as close together. And if you really can't tell at all what the trend is, that would be when we say that there's none, there's no correlation at all. In this picture, we have a whole bunch of different scatter plots, all of which would technically be showing positive correlations, but you can tell some of them are way stronger than others. The strongest of these would be number 2 up in the top right corner because most of those dots are in a line. There's like one outlier that you're looking at there, but it is a pretty strong positive correlation. What these dots are really showing you is all the different kinds of things that can happen with scatter plots and the fact that it's not really a perfect science, but you want to look at what the general trends are. Next week, we're going to actually be getting into how you do the math with correlations. And if you look carefully at the scatter plots you see here, you'll notice they have little numbers that are written above each of those. If you happen to have what we call a perfect correlation, where everything is absolutely in a straight line, you end up having what we call an R value of either -1 if it's a negative correlation, or +1 if it's a positive correlation. If the dots are all over the place, that would be 0. And basically, the stronger it is, the closer you are to either 1 or -1. So again, here we're showing you like all the different sorts of correlations you can happen. But what you want to know for now is just that a general trend is that if it's going down, it's a negative correlation. If it's going up, it's a positive correlation. And again, the closer it is to being in a perfect straight line, the stronger that correlation is. That's basically all we're doing this week, is just looking at what correlations are and what scatter plots look like. And again, we'll get back to doing the math on that a week from now after you've worked with your test.